So the origins of dairy consumption are debated, but humans have been drinking dairy milk for at least 10,000 years. And we've been making cheese for at least 7,000 years. I wish that we had time to talk about all of that, because I know all three of our panelists have an extraordinary wealth of knowledge on the subject. Food is who we are, literally and socially, economically, politically, and culturally. It makes up our symbolic and our physical DNA. We are what we eat. I'm sure many of you have heard that before. Many dishes, many meals will transport you across time and space. Many dishes will be an essential part of empowering you to chase your dreams, to accomplish your goals, to protect your agency, your health, yourself, and your family. It is essential to development at any stage of life. Food is medicine. Food is joy. Food can be really confusing too, which is why we're all here today, especially both to celebrate food and also to learn a lot more about it. What is healthy? What is balanced? Why does this make me feel good? Why does this make me feel bad? Where does this even come from? I ask that question a lot. We will address some of those questions today as we talk about the staple food that is dairy. So thank you for joining us for the first Food is Medicine panel. I am very excited to do more of these. And with that, I will invite our panelists to take the stage with me. Before they properly introduce themselves to you, we have Allison, we have Jennifer, and we have Hadi. Oh, hello. You want to introduce yourself with your name and what you do, Jennifer?
Sure. So I'm Jennifer Cruikshank. I'm the Dairy Extension Specialist with OSU. I'm also an assistant professor in the Department of Animal and Rangeland Sciences. And if you're unfamiliar with extension, it's kind of the third leg in land-grant universities. So we have education, we have research, and then extension. And so historically, that's been extending what is learned through research at the university out to our communities.
Thank you.
Hello, everybody. My name is Hadi Eshbari, and I'm an R&D manager with Tillamook County Creamery Association. I have a PhD in food science. I specialize in dairy chemistry. I've been with the company for 9 years, and I support our cheese and spreads business. So basically our cream cheese and butter in addition to our cheese. I've been in the field for more than a decade now. Really appreciate the opportunity of joining you guys today and be part of this panel and this great conversation today. Thank you.
Hi, everyone. I'm Allison Unger. I have a PhD in animal nutrition and food sciences. So before my role with National Dairy Council, I studied the impact of dietary fat on metabolic health. So perfect segue, because I know we're going to talk a lot about whole milk, for example. National Dairy Council, I'm currently the Senior Director of Scientific Affairs there. And for those who may not be aware, National Dairy Council is a nonprofit dairy research and education checkoff organization. So we cannot, we do not lobby or advocate, but we can educate on the science. And the reason that National Dairy Council was founded over 100 years ago was because farmers really wanted to help consumers make an informed decision when they're at the grocery store. How do dairy foods fit into my overall healthy eating pattern into the food system? So that's what I hope to do in my role.
Thank you. And then I'm going to start with a question for Jennifer. How does the human food system influence the cow's diet on the farm, and how are cow diets part of our food system?
All right, so those two things are a little bit more connected than most people might think. And the reason is because in our human food and fiber systems, we generate a lot of byproducts. So one example is oils coming from seeds, so from soybean or from canola, for example. So those seeds are pressed to extract the oil, but then what we've got are a bunch of crushed seeds that are left over. And there's not really a place in the human foods market for that item, but that's a really great feed for cattle. So, so we have byproducts coming from human foods and also fiber processing for that can be feeds that go into cattle diets, and they're nutritious. And what else are we going to do with them? Because like kind of the next best use would be composting. Another example is cottonseed. Whole cottonseed is another common byproduct that is fed to cattle. So once the cotton has been removed from the bowl, there's a little seed in the middle. And that's got some protein and some fats in it, and that can be incorporated into cattle diets. Oftentimes, byproduct feeds will also be from a more local source. So if there's a brewery nearby, so the spent grains coming from the brewery can go into cattle feed. In the Willamette Valley, we grow a lot of grass seed. That grass seed is processed at seed cleaning plants. And so the screenings that are coming, so sort of the stuff that didn't make the cut to be sold as grass seed, those screenings are a byproduct of that industry, and that can be mixed into cattle diets. And that's a really common byproduct feed in the Willamette Valley. But you would not find that in other places. Likewise, if you go to California, you would find almond hulls and sometimes citrus pulp as components in cattle diets, because again, that's a local byproduct that's readily available. And those can be incorporated into the diets, which of course has a big forage component as well. Usually that's fairly locally grown, so ensiled or fermented forages, and then dry forages like hay. And then grains. So those byproducts make up approximately a quarter of cow diets in the US. That's an average. So it's a really significant portion that is a waste product coming from other industries that can go to feed cattle and be transformed into nutrients for people. There's one more piece.
Yeah, I mean, however you'd like to answer that question. I mean, I definitely have a little follow-up too.
So they're very tied together. So our food systems, so human food systems and animal food systems are pretty connected.
I have a very, very brief follow-up question. As a proportion of feed for, I would say, or I would ask the most familiar dairy farm to you, what proportion of cow feed comes from local food systems? Like, for instance, I'm just going to assume the beaver dairy is.
Yeah, so our OSU dairy, we grow our own forages. So again, forages are going to be whole plants, right, that usually have been preserved in some fashion. So cows out grazing in a pasture, we call that self-harvested forage. So that they're just going and picking it themselves, right? For stored forage, that would be fed to cattle that are in confinement, or certainly cattle in the wintertime because it's too wet and muddy to be out grazing. That's going to be dried forages like hay, and that's going to be silage, which is fermented forage. And typically that will be particularly the fermented forages because that is harvested with a pretty high moisture content, so it's heavy. And transportation costs are generally high. And so like heavier, wetter feed that's a lot of transportation costs. You want to be growing that on the farm or very, very close to the farm. Dried forages like hay, they don't weigh as much. So your transportation costs for the volume of feed that you're getting are a little bit lower than they are for those really wet feeds. So you've probably seen hay trucks driving around, big semis, big giant bales of hay stacked on them. There's a lot of hay that's grown in central and eastern Oregon because the climate is like perfect for making really high quality hay. And that's like dairy cattle that's what you want to feed them, is really high quality alfalfa hay. And a lot of that's grown in Central and Eastern Oregon. So that's like local-ish, right? So those forages are generally going to be coming from somewhere close. At least a portion of your byproduct feeds ideally are coming from someplace close, like the soybean meal and the canola meal. Those, we don't really grow either of those things in much quantity locally in Oregon. So those are going to be coming from farther away, but there's areas of the country that grow a lot of soybeans, right? So there's a lot of it. So the price tends to be reasonable even to bring it from those distances. So the other component, typical component to dairy cattle diets is going to be a grain component. Oftentimes that's corn. That is usually not going to be grown locally just because it's produced in such high volume at such low cost in the Midwest. And it comes to the West Coast in train cars, right? So it's going to arrive in train cars, which is a fairly low cost, low carbon footprint way to transport goods. So oftentimes the grain component of the cattle diet will be coming from away. If we're talking about Oregon dairies. Obviously, if we're talking about a dairy in Iowa, there's corn everywhere that's produced for grain. So that's usually the one. Dairies may also get grain more locally. Typically, that's not going to be corn, so maybe they'll include some wheat or some barley that's grown very locally. They may include that in the diet as well.
And cow diets are coordinated entirely by cow nutritionists.
Yeah, so the vast majority of dairies do work with a nutritionist who formulates those diets, particular to the age group that we're talking about and also to the stage of lactation. So whether a cow, has recently calved and she's early in her lactation, or whether she's, been milking for 200 days, she's going to get, those cows are usually going to have a little bit of a different diet that's tailored to their needs.
And back a little bit closer to people, how has human preference changed milk? And in an answer, could you explain what A2 milk is to us, please?
Yeah. So in terms of human preference, how has that changed milk? The most, unless we're talking about fluid milk, which consumption of fluid milk, which I'm sure you can speak to, has been going down for several decades, although maybe it's leveling off. And that milk is standardized to 3.25% fat. So the value has been largely in the fat and the protein, because we get butter, we get ice cream, we get cheese. Those all have a low water component, right? So the solids components, the fat, particularly the fat and the protein in the milk, is really the value. So definitely that, like, we don't want to just drink milk, we want to make stuff from milk, like cheese and ice cream and yogurt. So that fat and protein is more valuable, is the more valuable pieces of the milk. Water is not particularly valuable. So the fat and the protein contents in milk have been increasing, and that's in large part due to genetics. So due to selection of cattle that produce higher fat and protein percentages in their milk, and then also working on the nutrition angle and how do we feed to improve those components in the milk. The other thing is your question about A2 milk. So you may have seen labels on containers of milk that are A2 milk. And what this is referring to is the beta casein. So one of the proteins that's found in milk is beta casein, and it comes in essentially two variants. And it comes in the A1 variant and it comes in the A2 variant. And these are genetically determined. So a cow who only has alleles or gene variants for the A1 version of that beta casein gene will only produce A1 versions of the protein in her milk. And a cow can be A1. She's only going to produce A1 protein in her milk. A cow could be A1, A2, so she's going to produce both variants. Or a cow can be A2, in which case she's only going to produce A2 variant beta casein in the milk. So that A2 milk is all coming from cows that have been genetically tested, that they are all only A2 variant cows and therefore producing A2 milk.
One question I have actually for Jennifer is that are the majority of the milk in the US of one kind or another, or it's a mix of different kinds actually?
So it is a mix, although there is a little bit of a shift towards more A2 because there is a price premium on A2 milk. So if a farmer has a herd and there are some breed differences, some kind of starting points for where breeds are for having a preponderance of either the A2 or the A1 alleles. So there is a shift, and it's very easy to do genetic testing and identify those individuals who carry it. So it's pretty easy to select for A2. So I think there's a gradual shift towards A2 milk based on its perceived value. I was just going to add, thank you.
So I was just going to add, Hadi is right that consumers, there are more consumers that are thinking about A2 milk. Typically, it's because of the digestive benefits that they are wanting from that A2 milk. So I just did want to say that looking at the body of evidence, there isn't robust clinical evidence to suggest that there's a difference between A1 and A2 milk. So, more science would be great to understand that question a little bit more. The other thing I wanted to add to, which I'll talk more about in my piece, but it's important to remember that dairy milk, for example, regardless of what type you're getting, organic, conventional, whole milk, fat-free, has its 13 essential nutrients. So the nutrient profile is the same. So I would just encourage you to, consume whatever dairy milk or dairy food that you enjoy eating, because you'll be getting those same essential nutrients.
Thank you. Wow. I think let's shift a little bit. Jennifer, I have a question for you, and I would love to then transition and get your input on this question, Hadi. But what do people and consumers, like the ones in this room, need to understand about how dairy producers use antibiotics and hormones on the farm, and any risks to underscore?
Okay, so we'll start out with antibiotics. So first off, antibiotics are a cost. So farmers are not excited to be using antibiotics because usually that means you've got sick animals, so they're not happy about that situation. But they're not kind of flinging antibiotics willy-nilly at everything because that doesn't make any sense in a cost-benefit analysis. So the most common application for antibiotics on a dairy farm are usually going to be to milking cows that have mastitis. So this is an infection of the mammary gland. And different pathogens that can cause those infections respond differently to antibiotics. So on a lot of farms, they'll be doing testing to know which organism is actually triggering that infection and then proceed accordingly. Because some pathogens respond poorly to antibiotics, so you're better off just letting her recover on her own. Other microorganisms that cause mastitis, a few of them, do respond well to antibiotics. And so that is the appropriate pathway forward. All antibiotics have on the label what's called a withholding period. And it'll have a withholding period both for milk and for meat. And so what that means is if the withholding period is, say, 48 hours, that means that from the last time you use that antibiotic on that cow for 48 hours, well, while you were treating her, and for 48 hours after that, you cannot put her milk into the bulk tank. It does not go into the human food supply chain. And then there'll also be one for meat. So if that cow is going to be sent to slaughter and go into the meat supply chain, that usually has a longer withholding period. And that is also stated very clearly on the label. as kind of a backup to, farmers policing themselves. When the milk truck arrives at a farm to pick up the milk from that farm to take it to the processor, before the milk is moved from the bulk tank to the truck, the milk truck driver takes a small sample of the milk, puts it in a little vial, stashes that in the truck, and then proceeds to pump the milk into the truck. And say there's like 2 more dairies on this milk truck driver's route. So they're going to stop at dairy number 2 and dairy number 3. And when they arrive at the processing facility, they're going to park the truck. They're going to take those 3 vials into the lab, and they're going to be tested for antibiotics. So there's a quick test that looks for antibiotics in the milk. If one of them is positive, it's bad. So that entire tanker load of milk will be dumped, and the farm who was guilty has to pay the other 2 farms for that volume of milk that was dumped. And your co-op or your processor is not happy with you, and you get a big black mark next to your name, and you'd better not mess up again. And so there's this system for catching antibiotic use. And so most farms are very, very disciplined about keeping track of their antibiotic use. And to the question of hormones. So hormone use really varies a lot farm to farm, and it's really used for reproductive management. So like humans may do IVF, and that involves a series of hormone injections. We can do kind of similar things with cattle. And so some farms may choose to do their reproductive management via the use of reproductive hormones. These are not really any different than hormones that the cow is producing herself. It's just in the timing. The timing is different, and we're manipulating the reproductive cycle. And again, not all dairies use reproductive hormones. Some don't use them at all. Others might just in a case of a cow who's not cycling normally, and you can give her a shot of, 1 shot to kind of trigger her. And again, these are naturally occurring hormones that are already in the cow's body, and the quantity that is applied is just at different times. And it's absolutely not anything to be concerned about. The only other hormone that's out there, and I think is probably the one that people think about when they're like, oh, cow hormones in milk. I mean, there's hormones in milk. There's hormones in all the foods except salt, right? There's hormones in plants. There's hormones in animals. So every time we eat, we're consuming hormones. So we shouldn't be afraid of consuming hormones. But probably the one that people think about is RBST, which is recombinant bovine somatotropin, or growth hormone. And when given to cattle, to dairy cattle, it can increase their milk production, but they don't necessarily eat quite as much. So it actually makes the milk production more efficient. And this was legalized decades ago. And folks were kind of like, oh, this is a new tool. Let's try this out. And the response from the public was not enthusiastic. And the response from the dairy producers was like, oh, we kind of tried it, and for a lot of people, they're like, that's not a good management tool for me. And because of the not so positive response from the public, a lot of dairy processors were like, okay, I think maybe we're going to just not do this. And so you'll see on milk cartons that, the milk is from cows not treated with recombinant bovine somatotropin, RBST. And I think you would struggle heartily to find milk that was in this country at this point in time, kind of nobody's using it. So it was a tool that folks tried. Public response, not great. So there's a little bit of pressure from the consumer side. And then even the farmers were like, this is not, we have other tools in the toolbox that we're gonna employ instead.
Fabulous. Before we hear a response from you, Hadi, back to hormones and other foods, you mean naturally occurring hormones versus synthetic
Yes, so
Using-
absolutely naturally occurring hormones.
Just wanted to make a clarification
Yes.
for anybody who listens to this in the future for posterity.
Yeah, hopefully they didn't stop like 30 seconds ago. Yes, so naturally occurring hormones. So plants have naturally occurring hormones. Animals have naturally occurring hormones.
Thank you.
When we eat them, we consume them.
Thank you.
So you want me to comment on antibiotic risk?
Yeah, RBST
Sure.
in the processing center especially.
I mean, the reason that we care about, offering products that do not contain antibiotic is obviously because we don't want for the general public to develop antimicrobial resistance for the obvious reason. We want them, when we need them to take antibiotic for them to be effective, they can still, use them. So, Alison actually very nicely mentioned it's a very quick test that we do when we receive those samples of milk, at the factory. So there are two most common ones. One is called the charm cell, and the other one is called SNAP. And they take a few minutes for you to get a reading, and you would know if your sample is positive for antibiotic residue or not. If you need to then send samples for whatever reason to confirm that there are actual antibiotics, there are more advanced tests such as like submitting samples to the lab, use chromatography tests such as HPLC and LCMS. You can also do microbiological inhibition tests. They are both techniques that can be used for this purpose. And yeah, it's the responsibility of the farmers to make sure that they really allow that withdrawal time that Jennifer actually talked about before entering their milk into the milk supply. I think that would be my answer on the antibiotic one.
Thank you.
Yeah.
So we have said hormones, antibiotics, A2. Can you tell us about what homogenization is?
Sure.
And how it's part of dairy product production?
Very cool. Just one more point before I move on to homogenization on the antibiotic. You can also imagine, other than the more important reason, which is not developing the antimicrobial resistance in the public, in the individual, we also care about the bacteria that we add intentionally in the production of cultured dairy products such as yogurt, cheese. They all use this group of bacteria that are called lactic acid bacteria. So you can imagine if your milk actually contains residues, even low levels of biotics, they can interfere with your processing, with the production of these products as well, which is obviously the less important. But from a technological standpoint, that is also in the industry, we care about that. Back to your question on the homogenization. So it's basically a mechanical process in which we are pumping milk through the homogenizer. And what it does is there is the homogenization valve. Think about it as a very narrow opening. So under high pressure, you're basically running milk through that very narrow opening. And by doing that, mechanically, you are reducing the size of the fat globules in milk. So fat portion of milk naturally occurs in the form of fat globules. And they are not uniform in size. They tend to be large. And by homogenization, when we run the milk through that narrow opening in the homogenizer, we are reducing the size of those fat globules. We are producing smaller size fat globules and more uniform size fat globules. And by doing so, the larger ones, because of their density and the fact that it's lower than the environment of milk, they basically rise to the surface. They separate from milk, they rise to the surface. So if you leave an unhomogenized milk, on your countertop for some time, you would see that you would have a layer of the cream on the surface of that milk. That's how you can tell if the milk is non-homogenized or it is homogenized. When you do the homogenization, you are basically, by reducing the size of the fat globules, you are distributing these smaller size globules throughout your product. So in that glass glass of milk, you have these smaller globules from the top to the bottom of that glass uniformly distributed, which that contributes, as you can imagine, and you're obviously as a consumer have experienced that, it contributes to the consistency of the milk you're drinking. So you can expect the homogenized milk to actually have nicer consistency, be more creamy, and has a richer mouthfeel. If it does, I guess the one question that you might have is how does it impact the nutrition profile of milk, or does it actually? I can tell you there is no negative impact or positive impact on the nutrition profile of milk, because you're basically just changing the size of one of the major milk components, which is the fat, and you're not doing anything beyond that. So your proteins, your carbohydrates, the lactose in milk, they're all remaining intact. All you're doing is basically, reducing the size of the fat globules, as I mentioned. There might be the globules that I talked to you about, the natural globules, they are stabilized in milk because of their membranes that surrounds them, which is, think about it as a sphere that has a membrane on the surface, and that membrane is called milk fat globule membrane. And that membrane, the components that produce that membrane are phospholipids that do have some health promoting impacts. They stabilize the fat globules. And during homogenization, one thing that can happen is that you might, because you're running that milk through that narrow space under that high pressure, you might modify, this membrane of the fat globules, basically, which again, it doesn't necessarily have been proven to show a negative impact, on the health promoting impacts of the phospholipids or any other aspects of the milk fat globule membrane. Having said that, we always, like on the food production side, on the dairy food production side, we want to make sure that we are preserving, the processing aspect, the technological aspects of milk. So for some products, such as yogurt, such as cream cheese or sour cream, it is a good thing, because you do actually want to have a homogeneous, a uniform texture in your product. That's why homogenization actually would benefit you. However, in natural cheese making, think about like cheddar cheese production. In cheddar cheese production, what you're doing, the basis of that is basically you're destabilizing the major protein in milk. The major protein is called casein. So throughout the cheese making process, you destabilize those caseins, and they interact with one another. They create this multidimensional network of gel network of the proteins, and all the other components of milk or cheese would get entrapped in that three-dimensional network. So the fat globules, some of your lactose, even some of the moisture and minerals would be entrapped in that three-dimensional network. By homogenization and creating these smaller fat droplets, because the fats in cheese is very loosely entrapped, actually. It's not necessarily interacting with the proteins. So when you create these smaller fat globules by homogenization, these smaller ones tend to not get entrapped in your three-dimensional network. So if you're making cheese, you probably don't want to homogenize your milk, because you don't want small fat droplets. You actually want large globules, so you can capture those in your curd and not lose them in the whey, which is the liquid that is left over from cheese making. So you really have to think about like what's the end goal of a process, and if homogenization would help you or it would have a detrimental impact on your process.
Sweet. Thank you. I have an additional question. When we strain away the whey, that is that byproduct becomes like a nutritional supplement. And when did we start actually capturing and marketing whey as a protein?
It's definitely more than a decade that whey has become, honestly, maybe the main product in part of our industry, in the dairy industry, because it's the most bioavailable, protein that is available to the humans. so that the nature has for us, has offered to us, basically. And in the process of making cheese, when you create that three-dimensional network that I just talked about, the secondary proteins in milk, that is called the whey proteins. So this is a term that is used like in two different ways. Whey itself is both the proteins in milk, the secondary major protein in milk, which is the most bioavailable protein, and it's a class of proteins. It's not one single protein. So there's beta-lactoglobulin, there's alpha-lactalbumin, and then, you know, in the cheese making, you cannot capture basically these proteins. They would end up in the liquid portion of your milk. So, and they would end up in your whey, which, you know, now because we have the technology to be able to concentrate these whey proteins and further in the downstream process, dry them and produce all these nice dairy powders that are available to us. Now we have a whole industry that just focuses on capturing, concentrating, and making all sorts of, you know, nutritious dairy powders, basically, that have so many different, not only from a nutritional standpoint, but also from, you know, a functionality standpoint. You can see whey proteins used in so many different products, even in the replacement of the conventional stabilizers such as gums. One very typical product that, you know, you could benefit from using whey proteins is cream cheese. In some products, if you look at the label, they are using gums. In some others, you see that there are no gums used. And typically, whey protein concentrates that have been functionalized, you know, in the process are used, you know, in the replacement of the texturizers. And what they do is basically one of their function is that they absorb the water in the system. So when you open a cup of cream cheese, you don't see all the free liquid on the surface. That means that they're doing their job and they're absorbing the water in the system, basically.
Thank you. So speaking to the availability of nutrients, let's move on to pasteurization and why we pasteurize raw milk, the benefits, the drawbacks, and this is quite a specialty in the director of the Moore Family Centers laboratories, but potentially alternative ways in which we are moving towards preserving raw milk that may preserve more nutrients than latent heat does.
Sure. First, why do we do pasteurization and what it is? As most of you probably know, is the process of heating raw milk at a specific temperature for a specific period of time. So one of the most common combinations of the time and temperature would be 160 degrees Fahrenheit for 15 seconds. That's the process that we call HTSD, which means high temperature, short time. So, and why we are heating milk? It's basically for two main reasons. The first one is that we want to eliminate all the pathogenic microorganisms in milk. So those are the microorganisms that can cause foodborne illnesses, bacteria such as Salmonella, Listeria, Campylobacter, E. coli. Those are the main targets of pasteurization. We want to eliminate those so they're no longer in milk if they happen to be. The other function, so we want to make the cheese, so basically make the milk and any product that is produced with it food safe. That's the main reason. The second reason, which is also very important for us as consumers and for the producers, is that we want to extend the shelf life of milk. And how we do that is by actually eliminating most of the food spoilage microorganisms. By HTSD, the time temperature I mentioned to you, you cannot eliminate all of them, but you can still kill most of those microorganisms. So that's why, you know, a pasteurized milk still needs refrigeration in order to, you know, if you want to enjoy it for a long period of time throughout the shelf life, you still need to refrigerate it. However, on the other side, we have, you know, another way of treating milk with heat that is higher temperature, such as we call that UHT, so ultra high temperature treatment, that by increasing that temperature to 280 degrees Fahrenheit to 307 degrees Fahrenheit for only a few seconds, you are keeping milk at that temperature. Then you are actually eliminating all the, you know, the food spoilage microorganisms. That's why the difference between the UHT milk versus the pasteurized milk is that UHT milk, because there is no food spoilage microorganisms, it can be shelf stable. You can actually keep it out of the refrigerator, and it would be good. It wouldn't go bad on you. There might be chemical degradation, which eventually also UHT milk, would go bad. You cannot enjoy it. But yeah, that's one main difference that you see between the UHT and pasteurized milk. What impacts, I guess, it might have on the nutritional profile of milk. So by doing the pasteurization, you're not really, negatively or positively impacting any of the main nutrients in milk, meaning the protein in milk, fat, the carbohydrates, the lactose, and minerals are staying really intact, at the high temperature, short time combination. Some of the nutrients in milk, the micronutrients, such as, vitamin C or folate, they are heat sensitive. So there you would see some reduction in the amount of those, micronutrients. However, to begin with, milk is not a great source of those nutrients. So because the pros of pasteurization, making the milk safe and, extending the shelf life outweighs the cons of it, we really plan to continue doing that, and we try to source those micronutrients from other foods versus milk. I think the second part of your question was actually on the alternative methods to pasteurization.
Yeah.
The pasteurized milk ordinance really calls for pasteurization as the gold standard method. But in recent years, in the last decade, there has been definitely a lot of research in alternative methods, such as, removal by using, basically membrane filtration. In membrane filtration, if you use microfiltration, you can essentially remove all the, bacteria, because the essence of that method is separating the components of milk based on their molecular weight. And usually these, microbes, when you use microfiltration, specific membranes, you can remove them. So that's one way of doing it. Or pulsed electric field would be another method of high pressure processing would be another method. Each of those methods have their pros and cons. Some of them might have negative impact actually on the technological properties of milk. Imagine when you are exposing your milk to very super high pressure, you can actually alter the nature and the structure of the proteins in milk and generate a lot smaller milk protein molecules that they do not perform the same way in your cheese making. So you can actually have negative impact on your cheese making properties, but the research is ongoing, and eventually we need to. I think the task of the scientists who are involved in such research is really to show that those methods are as effective, in offering food safe milk as the pasteurization is, and they need to submit all their documentation and research to FDA to be able to get approved for some of those methods, basically.
Thank you.
So lactose intolerance, again, lactose is the sugar in milk. And what many people don't realize is that lactose intolerance doesn't have to mean no dairy. There's such a spectrum of lactose among different types of dairy foods. So dairy milk has the most lactose. You can, of course, get lactose-free dairy milk, which is the same essential nutrition, just without the lactose. There's also fermented dairy foods that have naturally lower levels of lactose as well. And then a variety of lactose-free, as Hadi mentioned. The difference between milk allergy is that is an immune response to the protein that's in milk, and people who have milk allergy should avoid dairy foods. The prevalence is fairly low. It's about 1.9% in Americans, the general population. And so for either of them, as Hadi mentioned, we would recommend going to see your doctor and getting an official test and diagnosis. The symptoms can be so similar is the tricky part. So not only with lactose intolerance and milk allergy, but also when you think about celiac disease or Crohn's or things like that. So it's helpful to go to your doctor. And then especially for somebody who has a milk allergy, the doctor will most likely refer you to a registered dietitian. who can help you purposely meal plan. Because if you're removing dairy foods, I'll talk a little bit more about this, but because of the unique nutrient package of dairy foods, if you're taking those out of your diet, you have to be really careful to not, create nutrient gaps in your diet that could be detrimental.
Thank you. I have one question. We are 5 minutes to 6, so we can roll here, and then Allison, you're the ringer, and I'm counting on you to tell us about dairy fat and the milk fat globule membrane, if you would. Would you, in brief, tell us exactly how we produce fermented dairy products and the nutritional value that they provide?
Sure thing, yeah. So in the fermentation of dairy products, you are basically adding the lactic acid bacteria, as I mentioned earlier. And what lactic acid bacteria does is that it consumes lactose and converts that to lactic acid. By doing so, it makes it more digestible for the individuals who are lactose intolerant. In addition to that, it does so much more, like any other fermented food products. Through the fermentation, the metabolites of these bacteria, the lactic acid bacteria that you're growing in the food, they can actually contribute to the flavor and to the aroma of the product. So think about like all the nice cultured notes that you get from eating cream cheese or yogurt. That's all caused by the action of the lactic acid bacteria to a large extent. Other impacts is that also, because you're converting lactose to lactic acid, you're acidifying the environment of milk. So by doing so, you're destabilizing the major protein in milk, which is the casein. And when you destabilize the casein, they come to one another, they actually interact, and they make that three-dimensional network that I talked to you about, which is the basis for most of the dairy products that we enjoy and consume, such as yogurt. You need to do the same thing. You need to acidify your milk, basically. In cheese, you do the same. You start with addition of the lactic acid bacteria, then you add enzyme on top of that to make a firmer gel, which is your cheese versus your yogurt, basically. Other than the technological aspect of adding this lactic acid bacteria and fermentation in production of the cultured dairy products, also some of these lactic acid bacteria do have probiotic properties. The lactobacillus, the bifidobacterium, the streptococcus. Some of those strains have probiotic properties, and what it means is that they have benefits beyond just acidifying your milk. They are actually some of the known health benefits are gut health. So they actually attach to the inner layer of the GI tract, and they basically enhance the barrier of the gut health, and they prevent the harmful bacteria from entering your bloodstream. That's one of the good things. They also have positive impact on the digestion of the nutrients that goes through your GI tract. So the probiotic properties is another important aspect of the lactic acid bacteria also.
Thank you. Do you have anything that you'd like to add to that, Allison, before we start talking about saturated fat, which I'm sure everybody is just dying to hear more about?
Yeah, I think I can probably cover it in some of the questions.
Awesome. Thank you. Okay. So dairy products contain a lot of saturated fat relative to other foods. So if you would explain what the current federal recommendations for dairy consumption in this country are, and how those recommendations became part of federal dietary guidelines.
Sure.
Thank you.
Yeah. So the dietary guidelines for Americans is the federal nutrition guidance in the United States. And since 1980, which is the first DGA dietary guidelines that was developed, dairy foods, and when I'm talking about dairy foods, I'm talking about nutrient-dense dairy foods, milk, cheese, kefir, yogurt. They have been recommended as part of their own food group within a healthy eating pattern since the 1980s. So I do just want to say taking a step back before I start, that food choices, Adam did a great job of this actually in the beginning. Food choices are deeply personal. So, it's important to honor health as well as heritage, values, taste preferences. But it's also important that food choices are made with credible information. And there's a lot of misleading information out there. And I just checked on the stat this morning because I wanted to mention it, but in 2024, there was a statistic that said that 2% of nutrition information that's on TikTok is guided or is in alignment with the national recommendations. So that's 98% that's misleading or potentially untrue. So that being said, that's why we're here today. And many people don't realize, why dairy foods are their own food group. They have a really unique, dense package of essential nutrients. They can provide up to 13 essential nutrients, and they have been linked with many nutritional and health benefits with decades of research now. And did you want the exact recommendation?
I'd love to learn about grams
I didn't
per day.
answer your question.
No, you're fine. We're having a wonderful conversation.
Yeah. So according to the DGA, for Americans 9 years and older, it's 3 servings of low-fat and fat-free dairy foods. There are calorie and age-specific recommendations starting at 6 months of age, which is when complementary feeding begins.
Thank you. What I really, I'm biased because I consume dairy for, probably 2 of my meals per day have dairy in them. So I certainly bring some bias into this conversation. But I'm also married to evidence-based recommendations. So I really enjoy talking about and learning about dairy because there's an incredible amount of nuance in the subject because of processing. And of course, because of different genetic dispositions, changing the way people digest dairy, and of course, the perception that the food has. So to speak more to saturated fat, would you explain more about how dairy has gotten a pretty poor rap around particularly the diet heart paradigm, and some of the nuance that most recent research, observational findings are starting to unravel about the difference in saturated fat in dairy versus highly processed meats, red meat. I would love to hear your take on that.
Yeah, sure. I will do my best. So I'll start with the diet heart paradigm. This is a great topic and really important. So the diet heart paradigm was actually developed first in the 1950s. There was some initial research that was conducted that was looking at the relationship between diet and health. And this paradigm describes a relationship where consuming saturated fat increases levels of LDL cholesterol, which increases your risk of cardiovascular disease. And this was based again on research that was conducted, observational research in the 1950s. So since then, there has been, what many people don't realize, a growing body of research that may suggest that that relationship is more complex than was previously understood. And one of the studies that I really point to emphasize this is it was a systematic review that was published in 2020, and it looked at the relationship between total saturated fat intake or consumption and cardiovascular disease events. And it looked at 15 randomized control trials, which are the gold standard. They're considered to be the gold standard of nutrition science. And what's unique about these was that they were a minimum of 2 years in length. So that is a really long time for a clinical trial. And they looked at over 56,000 participants. So really large scale, robust, systematic review. And they really didn't find a meaningful relationship between, again, that total saturated fat consumption and those cardiovascular disease endpoints that they were looking at. So what's sort of, been a conversation in the nutrition science community is, why is this not like a tried and true relationship that we're seeing? What else is going on potentially? And one of the things has been food source of saturated fat potentially being more meaningful So thinking about, again, where is that saturated fat coming from in that food? Is it a dairy food? Is it red meat, for example? Is it a dessert that you're consuming? And is that maybe more important? And then also, is your overall eating pattern more important to your risk than just total saturated fat alone? And just wanted to link the numbers for people who may not know, but with dairy foods, about 70% of the fat in dairy foods is considered saturated.
Sweet. Okay. So for people who are not in a high risk population, so they don't have a number of risk factors that may lead to cardiovascular disease, type 2 diabetes. What does the research show as to a relationship for onset of cardiovascular disease, the number one cause of death in the world, and type 2 diabetes?
You're asking dairy foods and dairy fat?
Yeah.
Yeah. So,
And disease.
yeah. So, and thank you for that question. So this goes back to the first question that overall there is decades of research that has linked dairy foods, regardless of fat level, with health and well-being and reduced risk of certain chronic diet-related diseases like cardiovascular disease, type 2 diabetes being one of them as well. Other age-related diseases like sarcopenia and osteoporosis, so bone and muscle health being an important factor there. And so taking a step back, this goes back to my talking points earlier, but thinking about dairy foods at all fat levels, again, just wanting to level set that regardless of the amount of fat that you're consuming, if you're consuming whole milk versus fat-free milk or whole yogurt versus reduced fat yogurt, they have the same nutrition as their counterparts. So this is where it comes into keeping in mind your goal of a healthy eating pattern and, that flexibility that you want to bring to your diet to consume the, balance of nutrients and food groups. So wanted to put that out there, but thinking about dairy fat specifically, what's really cool about dairy fat is that it's actually the most complex fat in nature. It has over 400 different types of fatty acids. And so while 70% of fat in dairy is saturated, that's actually quite a large umbrella term. And if you go down a level deeper, there's many different types of fatty acids within that saturated fat umbrella. So there's short chain fatty acids, medium chain, branched, odd chain. They're all found uniquely enriched in dairy foods, and mechanistic research has linked these with potential benefits for inflammation, for gut health, lipid metabolism. So the research is emerging, but I will say that there's, when you think about, that's kind of a head scratcher. Why is everything I've learned, whole milk, should be bad for your cardiovascular health, and we're not seeing that? Is there a potential role of the dairy fat itself, inclusive of that whole, all of the benefits that the rest of the dairy food package is bringing?
Thank you. We are almost at a place where we can take live Q&A, and I'm just thinking about any other questions. So we discussed cardiovascular disease and type 2 diabetes. Did you mention the correlation between obesity that we've noticed between like full fat and non-fat consumption?
So what I can tell you, I'm thinking of two potential answers to your question.
Yeah.
But let me know if I'm going in the direction you're thinking. So again, thinking about dairy foods as part of a healthy eating pattern. So I'm not just talking about dairy foods. I'm talking about, meeting your dairy food recommendations, but also recommendations for fruits, vegetables, proteins, grains. When you're looking at that whole balanced diet, dairy foods can be a really important component to weight management. They have high quality protein. They also have several immune supporting nutrients, bone and muscle supporting nutrients. And again, going back to that nutrient dense package, They can provide a lot of essential nutrition for a relatively small portion size. So that can play, an important role in weight management. Going back to, the question of maybe fuller fat dairy foods and that they're higher calories. Is that where you were going?
Yeah.
So yes, it's true that fuller whole milk dairy foods, reduced fat dairy foods have more calories because they have that content in them. But what we've seen in the literature, again, going back to there's growing body of evidence that shows that dairy foods at all fat levels can promote health, reduce risk of chronic related disease. That indicates that there is room for fat flexibility in the diet. And so if you're not familiar with that term, you might be intuitively aware, but it's essentially saying there is room for, choices of moderate or fuller fat dairy options within keeping in mind an overall healthy eating pattern. And science does support this. So we have some modeling research that's shown that Americans can choose up to 1 serving of whole milk or reduced fat dairy foods as part of their diet. There's a little bit of what we call discretionary calories in the DGA recommendations. So that is potentially where that can come from, and still stay within energy levels, and also recommendations for saturated fat and sodium as well. Was there a second part to that I'm missing?
No, I mean, that definitely sums up dairy being a part of a balanced dietary pattern. And just to wrap up before we move on to live Q&A, which we have a nice series of questions here, I am curious if you can speak to the difference in dairy recommendation that a registered dietitian may make for people who do have cardiovascular disease or type 2 diabetes versus a population that's not necessarily at risk.
Yeah, so that's a really important question. I would say that that's a really individual recommendation. And so somebody who would have a particular condition would be working directly, ideally with a registered dietitian who can help them meal plan to meet their exact needs. So I don't know that I could necessarily comment on a recommendation for a population that has a specific disease. I think that's a pretty personal, tailored choice.
Sure. Yeah. I just wanted to
Yeah.
see if you had a specific take on that question. So if a question that I ask entices any of you, please, give me a glare, and I will definitely make sure that you are on the microphone. Let's see. Does the lack of lactose affect the nutritional value of low lactose dairy foods? Can we clarify that?
Think about lactose as one of the nutrients. So if you can actually digest lactose, if you have the lactase enzyme in your body, or if you're taking a lactose-free product, because you're not totally removing necessarily, you're converting lactose to its monosaccharides, to its components, the glucose and galactose, and each of those would still have nutritional value. So yeah, I mean, if you are removing one of the nutrients from a product, you are going from a calorie intake, you're basically making so much less of that calorie in your finished product, basically. However, I mean, it really depends on what's the end goal of a product and what does lactose do to your product, both from a flavor standpoint, from a technology standpoint. Like in cheese making, you really don't want to have a lot of lactose. The function of lactose is really to produce the acid, and then to as a nutrient, feed the lactic acid bacteria, and that's the function of the lactose. So that's why you don't have a lot of residual lactose in a semi-hard or hard cheese. You actually removed most of it in the production. It went with your whey, basically. Whey has a lot of lactose in it compared to the proteins in whey. And yeah, I mean, however, if you're consuming, fluid milk, obviously all the lactose is still in there. So it really varies from product to product categories, and it depends on what you want to get from a specific process and a specific product that you're making, basically.
to some in the way that I perceive this question, at least. Lactose is a disaccharide. So there's basically two monosaccharides that are combined to create lactose. And when you present a synthetic lactase, it breaks that lactose into individual monosaccharides. So as far as is there a difference in calories? Are there less carbohydrates? It remains the same whether or not you break that disaccharide down into individual components or not. That's how I perceive this question. So I just wanted to add that. Really quick.
But I would also encourage you, if you care about it, as a researcher, as a scientist, look at the label, see how much, I guess, added sugar is there in dairy products. If it is fluid milk, you're not going to have added sugar. So if there is carbohydrates there, that's really your lactose. So if you are using membrane filtration that I talked about, you're removing the lactose physically. So you're going to have so much less lactose in your system to begin with. If you are doing a combination of membrane filtration and adding addition of the enzyme, then really the nutrients that are available through lactose in the system is going to be so much different.
So it depends on the mechanism.
Process that you use to produce the lactose-free product.
Wonderful. Thank you. That's perfect nuance to that question. This is another question for you, Hadi. Why does shredded cheese seem to melt in a different way than blocks of cheese?
Very cool question. Cheese is very near and dear to my heart, so I really am liking this question. So shredded cheese, really think about it. Are you talking about shredded cheese that you buy from the store, or this is a block of cheese that you bought from the store and you shredded it yourself? The key difference there is the use of the ingredient that we call anti-cake. So, and typically what it is, it's either starch or cellulose, and the function of it is just to prevent those pieces of shredded cheese from we basically call it caking, or you don't want them to clump together. So, but it does, depending on the type of anti-cake. If you're using a potato starch, you're using a cellulose, are you using a modified starch versus a native starch that is not processed necessarily? It can impact the melting behavior of your cheese. So, that's the key difference that you would see when you put a slice of cheese, in the oven, or you put a pile of, shredded cheese that you bought from the store. That's one key difference, both from a melting standpoint, because that starch is going to act like a barrier in terms of the heat transfer to your cheese. So you might get some sort of melt restriction. Cellulose, for example, can cause some melt restriction. However, potato starch would not give you that melt restriction. So not all the anti-cakes are really created equal. Based on the type of anti-cake, you might or might not experience that melt restriction. The other aspect of it is also browning. Part of what you want to see, like on the top of a pizza, you may actually want blistering and browning of the pizza. So use of starch actually would promote that browning, to happen.
It's an incredibly in-depth answer. Thank you. That's awesome.
I could go on.
That's all I was thinking. This entire panel, like I said earlier, I'm like, okay, we have an hour. It's already been an hour and 18 minutes. So hopefully another 12 minutes and we can wrap up. But I'm just like, if I knew some of the questions that I could ask you and all of you, I mean, we could be here for days. And I say that in the most heartfelt way, of course. I like this question, and I think, Jennifer, I think this would be a good one for you. And I want to ask it exactly how it was asked or sent to me by Clay. Thank you, Clay. Health is wealth, but healthy food seems to require wealth. How much does buying organic dairy actually matter?
Okay, so my interpretation of this question of how much does it matter? So I'll give a brief rundown on what organic production means, like what it is, what it means to be certified organic. So in a livestock operation in the United States, to be certified organic, all of the feed has to be organically produced. So that's the same guidelines for producing plants organically, so for human food or for animal feed. So the feed has to all be organically produced. There's a grazing requirement. So all animals that are 6 months old or older, that are ruminants, so this is cattle, sheep, and goats primarily, they need to be grazing for at least 120 days of the year, where they get at least 30% of their dry matter intake coming from the pasture that they are grazing. So there's a grazing requirement. There's a prohibition on genetically modified organisms in organic production. So really that's going to be, you can't feed GMO corn, which is going to be organically produced corn. So it's going to be not genetically modified. And one of the big ones is a prohibition on the use of antibiotics. So this can be a little bit tricky because cattle sometimes get sick. They sometimes get bacterial infections where antibiotics would be appropriate. But their use is prohibited in organic operations with kind of a slim exception. It's sort of like to save the life of the cow. So if she's got a systemic bacterial infection and for animal welfare purposes, like you really should treat her. But what that does is that makes her not organic anymore. She is not an organic cow. So when she's treated with antibiotics, you saved her life. She's recovered. Yay! Her milk cannot go into your organic milk tank anymore. So usually what that means, if she does, she recovers, she's great, everything's fine now, she would get sold to a conventional dairy because she doesn't fit with your organic operation anymore. So those are the basics, and there's an inspection component. So there's an organic certifier that would come and visit your organic farm once a year, and they really are looking at your records. So pull out all your records for where all your feed came from, and what was your grazing, how did you allot that, et cetera. So where it comes down is, and I should mention, so there's also been a fair number of studies that have looked at comparisons of the nutrition of organic and conventionally produced milk. And really what it comes down to is in basically all of those studies, it comes down to diet. And so whether they were, the grazing piece is really kind of the key piece. And what that tends to shift is the fatty acid profile. So Allison was talking about, there are a lot of different fatty acids in milk fat. And if you kind of look at it at that, sort of microscopic level, you will see a shift with more grazing. The fatty acid profile will shift in a fairly predictable way. But it's really due to diet. One of my favorite studies was in New Zealand, and the study was a bunch of paired dairy farms that were right next to each other. So they're experiencing the same microclimate. They were all grazing because almost all dairy cows in New Zealand spend their whole lives on pasture. And so the cows were eating the same thing. They were living in the same locations. And the only difference was this farm is organic and this farm is not. And the milk was as identical. There was a few oddball carbohydrates that were like a little bit different. So the question kind of comes around, there's minor differences between organic and conventional, mostly with fatty acid profile, mostly due to the fact that the diet has a grazing component to it, which is seasonal in most places. So they're not going to be on pasture year round. It's going to be through the grazing season. And then the question is, does that matter? Do those very small differences actually matter?
I believe from a nutritional standpoint, the research really doesn't support organic milk is better for you, or organic any, I guess, dairy product. Yeah, I mean, you also should keep in mind that, in organic products, you cannot preserve them in any way necessarily. Think about like shredded cheese that we just talked about. A common, mold inhibitor that we use is nanomycin, which is a natural mold inhibitor. And in organic shredded cheese, you cannot use it. And you really are not going to have a long shelf life. Think about how much food waste that would cause. I don't want to encourage or discourage you from like use of organic milk if you really believe you want to do that. But if from a nutritional standpoint, you don't have enough scientific evidence that this is better for you, and I guess thinking about like the food waste aspect of a shorter shelf life with organic products, that is, that applies to many different types of food products. You have to keep in mind that, what are the pros and cons of using it or consuming it? Yeah.
Thank you, both of you very much. I have a follow-up question, and then I think we have room for about 2 more, and then we'll wrap up and go to dinner. So first off, do cows enjoy being milked? What do they think about being milked?
I think they're for it. So they're on a farm that's milking their cows in a milking parlor. When it's milking time, like the cows go, they're ready to go. They're very routine based. Also, there's a fill component to the mammary gland. At some point, that's going to become uncomfortable. And so, yeah, they would like the milk to be removed, please, and thank you. On farms that have automated milking systems or robotic milkers, those typically are, the robots are where the cows are in the same barn. And so the cows choose when to go to the robot, more or less of their own free will, with very few restrictions. They usually get some really high concentrate feed in the robot. So you will have the cow who's like, I want my snacks. And so they get blocked. Like, no, you have to wait at least like 4 hours. You can't just keep coming back through for snacks. So that's been really interesting as those have come online in the last like 20, 25 years, and collecting data about cow behavior has been really fascinating. And so when given the choice, a cow, and there'll be individual differences, but also like early in lactation, when they're giving more milk, they're going to make more visits to the robot. Later in lactation, when their milk production is tapering off, they're generally going to make fewer visits to the robot. So kind of what we've seen is sort of giving free will to the cows. They visit like 3 or 4 times, but like they go, right? So so milking is a positive part of their day. And when they're in the actual milking process, like cleaning the udder machine on, like maybe 7 minutes, maybe. Depending on how much milk they're giving and how fast they milk out. So the actual amount of time that the machine is on is a very, very small proportion of their day.
Thank you. That was perfect. Last question, and I'll leave this one for any of you. How can the microbes in milk benefit my health? I know we spoke to that a little bit, but probiotic foods in the last decade have become a lot more prevalent in the general public's nutrition vernacular. So I think it would be a nice thing to wrap up on.
Yeah, I mean, the microflora of milk, not all of the bacteria there are necessarily good for you, and they're not necessarily probiotics. So if you really want to have a probiotic product, you need to add it intentionally. And it's not just addition of it. You need to make sure that throughout the shelf life of that product, you actually have enough number of those bacteria to be able to really claim any health benefits from them. That microflora of milk does have other, good bacteria that are not necessarily probiotics, such as the non-starter lactic acid bacteria that, some of them are really good contribute to the flavor of the product that you're making. In Tillamook, for example, we produce most of our cheddar cheeses with heat shocked milk. It's not necessarily the legal pasteurization, and you can do that legally. You just need to age your cheese for like 60 days before you can release it. But what we are doing in that heat shock process, we are preserving some of these non-starter lactic acid bacteria that we know that they contribute some of these nice flavors and complexity of the end finished cheese, basically. But back to the probiotics, it's really you need to add the bacteria, like the bifidobacterium, to your product. You need to make sure that the product that you're choosing as a carrier for your probiotic also has the right environment for it. Like cheese is not necessarily the right environment because it's harsh for the microorganisms, and you rarely can survive. The microorganisms cannot survive the conditions of the cheese, especially throughout the aging period and shelf life of it. That's why you're not going to end up with enough number of probiotic bacteria in your product. Versus yogurt, it does have a short shelf life to begin with, and it has the perfect conditions for the probiotics to be added and be delivered through yogurt, for example.
Allison, do you have anything you want to add to that?
Sure.
Thank you.
So I'll say kind of more broadly that fermented dairy foods, which again is certain cheeses, yogurt, kefir, they may have a sort of distinct and complementary benefit for health in relation to overall dairy foods. There is food matrix science in general is this sort of emerging area of research that looks at not only the nutrients in foods, but also bioactive compounds, and then how they all interact together within that whole package of a food. And so that research, as that has been sort of emerging, part of that has been looking at the role of microbes and the live and active cultures that may be in fermented dairy foods. So I think there's a lot more to learn. It's a super exciting area of research. But I think what we can see is, does it explain some of the benefits of fermented dairy foods? Like cheese is a great example. Hadi could tell you more about this, but cheese is a food that's high in saturated fat, it's high in sodium, and yet we see it's linked with neutral to beneficial outcomes related to blood pressure and cardiovascular disease. So why is that? I think the whole food matrix probably is playing a role there. Yogurt is another one where there's actually a recent, in 2024, the FDA released a qualified health claim for yogurt and its potential role in reducing the risk of type 2 diabetes. And so this is for yogurt as the food. It's, so regardless of if it's a flavored yogurt or whatever fat content it may have. So that's the whole food that is playing a role, and goes back to that food matrix science. So I think just looking at it broadly, I think there's a lot more to learn about what are those, live and active cultures doing beyond the fermentation. But we're definitely seeing that there is a very distinct and powerful benefit of fermented dairy foods within the healthy eating pattern.
Sweet. Yeah, I'm in ways that I'm sure I look forward to discovering in my own lifetime. The gut-brain axis and all of the different possibilities with gut health. So, well, that's about that. So thank you all very much for coming, and please give a round to our panelists. Thank you. And if your question did not get answered, feel free, if you're in the shower later and you're like, man, I really wish I asked that question. That QR code is still live. So if you ask a question, I can get a response to you. If you maybe include your email in your response, that'd be fabulous. So thank you guys. Appreciate it. This was fun.